Hello students, this is lecture class 2 on refrigeration and air conditioning in continuation of lecture class 1 on refrigeration and air conditioning. Today we are going to discuss about the types of refrigeration system and difference between vapor compression refrigeration system and vapor absorption refrigeration system. So there are two types of refrigeration systems are there: vapor compression refrigeration system and vapor absorption refrigeration system. This VARS is also called as aqua ammonia refrigeration system or ammonia absorption refrigeration system. First we will discuss about the vapor compression refrigeration system. So now you can see here the first compressor. Next compressor you have condenser. Next receiver is there. Next expansion valve is the evaporator, and again it will come back to the compressor. So in between you have the pressure gauge also. So now we'll start with the first the functions of each and every component of the vapor compression refrigeration system. Compressor. What is the job of a compressor? Compressor job is to compress. So compress means it has to convert low pressure into high pressure. That's very important thing. And low temperature into high temperature. So compressor converts low pressure into high pressure, low pressure into high pressure, low temperature into high temperature. Next, condenser. Condenser job is to convert vapor into liquid. The condensation means what? Converting vapor into liquid. That is called condensation. Thus condenser will do that work. Receiver or a tank. So receiver or a tank, it does not have any technical work, but it will store. Okay, it is a storing device. It will store the refrigerant. Next, expansion valve is there. So an expansion valve, the main job of expansion valve is to convert high pressure into low pressure and high temperature into low temperature. Again the evaporator is there. Evaporator, it has to make the refrigerant to evaporate. So that is the main function of the evaporator. It is a copper coiled tube. Evaporator is a copper coiled tube. You might have observed this in your fridge or refrigerators. So nowadays the refrigerators are not coming with the that is open type. So it is encased or it is a closed one. Okay. Olden days and all the refrigerators were, we can see the evaporator, that copper coil tubes you can very well see, but nowadays it is concealed. Okay, so you can see that in shops, that is repair shops, you can see that copper coil tubes which are there backside of your fridge. Okay, so evaporator main function is to evaporate the refrigerant, liquid refrigerant to the atmosphere. So this is the refrigerated space, the square what we have drawn here. This is the refrigerated space. Refrigerated space means what? That space we have to convert, that is we have to make into a cool space. Okay, here temperature is more, so this temperature we have to remove and we have to throw it to the atmosphere. So that we can make it as a, we can say as a refrigerated space. That is the temperature is say 10 degree, 12 degree, the temperature what the less we require cool, the space should be cool. Okay, this space only we have to make it we have to make a refrigerated space. Okay, cool space. Next, pressure gauge. Pressure gauge, it is used to check the how much pressure is there in the compressor. Okay, so these are the various functions of or the responsibility, you can say the functions or responsibility of each and every part of a vapor compression refrigeration system. Now, so first we will start from this evaporator. Okay, so from the evaporator you can see a vapor refrigerant at low pressure and low temperature. So vapor means what? Gaseous state. Okay, the vapor, the refrigerant is in vapor state, it will come to this compressor. It will come to the compressor. So vapor refrigerant, refrigerant already yesterday we have discussed so many refrigerants. So ammonia, carbon dioxide, so many refrigerants are there. You can take any one refrigerant, and this that is in the state of vapor. Okay, gaseous state, it will come to the compressor. So in compressor what will happen? The vapor refrigerant which is at low pressure, it is compressed. Okay, how it is compressed? By means of a motor. So it is driven by the motor. Compressor is driven by the motor. So this the vapor refrigerant is compressed, and the low pressure and low temperature is converted into high pressure, high temperature vapor refrigerant. It will come to the, it will come out. Okay, from this it will come out. So it is coming out, it will be a high pressure, high temperature vapor refrigerant, vapor state. Then it goes to a condenser. In condenser, so condensation takes place. So condensation means the vapor has to be converted into the liquid. Okay, so there the condenser will do the job. So vapor is converted into the liquid. So liquid refrigerant which is at high temperature. So pressure will not change, it will be at high pressure only. The high pressure, high temperature liquid refrigerant will be stored in the receiver or a tank. Temporarily it will be stored. From there it will go to the expansion valve. So in expansion valve, the main job of expansion valve is to convert high pressure into low pressure, high temperature into low temperature. So the liquid refrigerant, when it passes through the expansion valve, expansion means you just understand the word expands. Okay, so that means you are allowing more amount of liquid refrigerant to pass, that is expands. Okay, so expansion valve converts high pressure, high temperature into low pressure, low temperature liquid refrigerant only. Low pressure, low temperature liquid refrigerant. Okay, again it will come to the evaporator. So in the evaporator, this is the refrigerated space as I told you. So here what will happen, when it comes to the evaporator, the liquid refrigerant which is at low pressure and low temperature, so it is going to evaporate. Okay, this is going to evaporate. Liquid refrigerant will evaporate. While it is evaporating, the heat which is present in this refrigerated space, it will carry that heat and it will go to the atmosphere. Which is the heat which is present in this refrigerated space, it will take that heat and it will evaporate. So again that refrigerant, that vapor refrigerant, again it will come to the compressor. Thereby one cycle of operation is completed. Okay, again I will repeat here. So the vapor refrigerant, the low pressure, low temperature. So low pressure, low temperature vapor refrigerant will come to the compressor. Low pressure, low temperature liquid, low pressure, low temperature, the vapor refrigerant will come to the compressor. So in the compressor, the compression takes place. Compression takes place. So the low pressure is converted to high pressure, low temperature is converted to high temperature, and the output of this compressor is high pressure, high temperature vapor refrigerant, and it passes through the condenser. In condenser, condensation takes place. There is vapor state is converted into liquid state. So vapor refrigerant is converted to liquid refrigerant, and it will be stored temporarily here. That is called a receiver or a tank, and from there it will go to expansion valve. So in expansion valve, the expansion valve converts high pressure, high temperature liquid refrigerant into low pressure, low temperature liquid refrigerant. Again from there it will go to evaporator. The evaporation takes place. Evaporation means what? Converting again liquid into vapor state is called evaporation. So while it is evaporating to the atmosphere, when the refrigerant is evaporating to the atmosphere, the heat present in this refrigerated space, it will take the heat present in the refrigerated space and is going to evaporate to the atmosphere. Okay, again the vapor refrigerant, it will come to the compressor. The one cycle is completed. So here several cycles it has to repeat in order to cool this space. In order to cool the refrigerated space, the several cycles it has to take place. So that means initially the refrigerated space is around, let us say, some 25 to 30 degrees Celsius. So this 25 to 30 degrees Celsius you have to bring to the 10 degrees Celsius. It is your target. It is your required level, 10 degrees Celsius. That means several cycles it has to repeat, and after that, once it is 10 degrees achieved, so compressor will off. So compressor will off momentarily, and after some time again the compressor is going to on, because from 10 degree it will increase to 12 degree or 14 degree. So thermostat will be there, automatically it will switch on and switch off. When the temperature is increases 10 degrees Celsius to 12 degrees Celsius, then a thermostat will trigger. So it will, compressor will on. That extra 2 degree what it has gained from the atmosphere outside, so again it will cool that space, and it will throw the temperature, the higher heat to the atmosphere back. Okay, So again it will maintain the 10 degrees Celsius. The same way, so frequently the compressor will be on and compressor will be off based upon the temperature. Okay, the temperature increases, the compressor will on. The temperature remains as it is, compressor will be in off condition. Okay, so that is why we say refrigeration, it has to remove the heat and it has to maintain that heat, maintain the temperature. Temperature may be 10 degree or 5 degree or it may be anything, 12 degree, whatever desired temperature. So the temperature that it has to maintain. For maintaining the refrigeration system is required. So once, say for example, once you cool it, again if you leave it, what will happen? What will happen? Again temperature after some time, because outside temperature is high, the temperature will come from higher body to a lower body. Again the entire thing will increase. It is just like that. Say for example, you are studying. Okay, today you are studying about this, and after this you have to keep it in mind. Means what? You have to keep it in mind means you have to read again you have to read, again you have to read. Whenever you feel that you have forgotten this concept, again you have to read. That is what. So that means you want to maintain the concepts, you have to be in touch with the subjects. In the same way, here also vapor compression refrigeration system or refrigeration process, you have to maintain means the compressor should be on frequently, it should be off frequently. When it is off, whenever the temperature it maintains at a target level, so then it will be off. When the temperature increases, because heat flows from higher temperature from outside to inside, so at the time the compressor should be in on condition. So this is about the vapor compression refrigeration system. So in a vapor compression refrigeration system, vapor refrigerant is used as a working agent. The refrigerant used is ammonia, carbon dioxide, freon, 12 or sulfur dioxide. The refrigerant undergoes a change of phase from vapor state to liquid state and liquid state to vapor state during the cycle. So the parts of VCR, as I told you, evaporator. So evaporator, it is in the form of a copper coil tubes installed in the refrigerated space. The evaporator tube is connected to a rotary compressor. The delivery side of the compressor is connected to a condenser or a cooler. In evaporator, the liquid vapor refrigerant at low pressure and low temperature gets evaporated into low pressure and low temperature vapors. The refrigerant absorbs heat from the surrounding space and thus reduces the temperature of the surrounding space. This is about the evaporator. Compressor, it has to compress the low pressure vapor into high pressure vapor and the low temperature into high temperature vapors above the atmospheric pressure and temperatures. The compressor delivers the compressed vapor to the condenser. An electric motor is used to drive this. The condensation also copper coil tubes. It is used to cool the high pressure and high temperature vapor. That means it will convert vapor into liquid. Next, expansion valve is there. Expansion valve, so it has to convert high pressure into low pressure, high temperature into low temperature. Receiver, it is a small storage tank which is used for storing liquid from the condenser. Next, working principle. So working principle is suction and compression of vapor refrigerant, condensation of vapor refrigerant, expansion of refrigerant, evaporation of refrigerant and cooling of the space. This is the 4 stages. In 4 stages, the vapor compression refrigeration system takes place. First, suction and compression of the vapor refrigerant. Suction means, what is suction? That is vapor refrigerant which is coming from the evaporator to the compressor. That is called suction. Okay, the vapor refrigerant enters into a compressor, and compression of vapor refrigerant, that is compressing a liquid vapor refrigerant by the compressor. Condensation second stage. Third stage is expansion, that we have seen. Last stage is evaporation of refrigerant and cooling of the space. So this is about the vapor compression refrigeration. It is a big question. It is 8 to 10 marks question. Vapor compression. The need sketch explain the working principle of vapor compression refrigeration system. You have to draw the sketch and you have to explain each and everything. Next we go for the vapor absorption refrigeration system. So it is also very important thing from the exam point of view. Vapor absorption means works on the principle of refrigerant in the cold water. Okay, it differs from vapor compression. How means, here we are not using compressor. Instead of compressor we are using absorber. Generator and pump in the vapor absorption type. So in this we are using ammonia. So it's basically is meant for ammonia only. That is why we call it the ammonia refrigeration system. And it is also known as aqua ammonia refrigeration system because we are using a water. Okay, aqua means water. Water and ammonia we are using. That is why we call it the aqua ammonia. Are used in large quantities when dissolved in homogeneous mixture of ammonia and water. It is known as aqua ammonia. On subsequent heating, it gives off vapors. This is the principle of working of ammonia absorption refrigerator or vapor absorption refrigeration system. Now looking into the figure here. So now we will start from this evaporator. That is, from evaporator we are going to get a ammonia vapor. From evaporator we are getting a ammonia vapor. So ammonia vapor, it will go to the absorber. It will go to the absorber. So in ammonia vapor, it will go to the absorber. Okay. Now when it comes out, it will be a strong ammonia solution because ammonia vapor is a weak solution. Okay, it is a weak, concentration is very less. So that is why in this we are using ammonia and water, both are using. So low pressure weak ammonia solution, it is sprayed into the absorber here. So it is coming from that the heat exchanger. Low pressure weak ammonia solution is sprayed here. So once it is sprayed, once it is sprayed into the absorber, ammonia vapor is there. So ammonia vapor absorbs the water and ammonia solution. It becomes a strong solution, strong ammonia solution. Okay, low pressure strong ammonia solution. Strong ammonia solution means what? The concentration of the ammonia is more. That is called strong ammonia solution. Okay, so low pressure weak ammonia solution. So ammonia plus water, it is there here. Okay, so low pressure strong ammonia, it becomes a low pressure strong ammonia solution. I will repeat again here. Ammonia vapor from the evaporator, it enters to the absorber. Okay, from the heat exchanger, low pressure LP, low pressure weak ammonia solution is sprayed here. So low pressure weak ammonia solution means here you already water is there. So water plus ammonia, weak ammonia, water plus weak ammonia. So ammonia vapor absorbs. Ammonia vapor is absorbed by the ammonia solution. Ammonia vapor is absorbed by the ammonia solution. Our ammonia solution you got, so from here water plus ammonia, so low pressure weak ammonia solution. So ammonia plus water, that is ammonia solution. It absorbs the ammonia vapor and it becomes a strong ammonia solution. But it is a low pressure only. Low pressure. So this low pressure we have to convert into high pressure. Because of, for that only we are using the pump. So pump converts low pressure into high pressure. Okay, pump converts low pressure into high pressure. So when it comes out from the pump, it will become a high pressure strong ammonia solution. High pressure strong ammonia solution. Next, this high pressure strong ammonia solution, it goes to the generator. It goes to the generator via heat exchanger. Via heat exchanger is there. So here what will happen in generator, the heating coil is there. Generator heating coil is there. So this ammonia solution is heated to convert into vapor. Okay, this is the first time. Okay, because 2 times phase change takes place. This is the first time. I am talking about the first time. So heating coil is there. So this heating coil, it heats the ammonia solution and converts that into vapor, ammonia vapor. So coming out is ammonia vapor. So here heat exchanger, while it is going through the heat exchanger, so the ammonia solution, so slightly it is warmed here in the heat exchanger because the vapor goes, ammonia vapor goes out. Here comes out, here the ammonia, strong ammonia solution comes through this. There is a heat condition, warm condition. So that warmness will be given to the ammonia liquid. So that warm solution will go to the generator. Sometimes we have to heat here. Okay, so this ammonia solution will go to the generator and further heating takes place. That solution that is converted into ammonia vapor. Okay, so ammonia vapor. So remaining solution, the high pressure strong ammonia solution, okay, is a strong solution. It will come to this heat exchanger. From there it will go to the low pressure weak ammonia solution. Okay, so I will repeat again. So from the pump, the high pressure strong ammonia solution, it will go to the generator. So while going to the generator, there is a heat exchanger is there. So heat exchanger, slightly it will warm the solution. High pressure strong ammonia solution will be heated or warmed. Okay, some sort of warmness will be given to the solution. Okay, and directly it will go to the generator. Generator, again here the coil is, heating coil is there. It further is heated so that it has to convert a solution liquid into a vapor. So it, when it comes out, is ammonia vapor will come, but remaining that ammonia liquid, the ammonia liquid will, once it will be in low pressure weak solution. That solution, okay, it will come to the absorber. It will come to the absorber. So from there, this ammonia vapor, high pressure ammonia vapor, it will go to a condenser. The condenser condensation takes place. That is, vapor is converted into a liquid second time. See, vapor is converted into a liquid, high pressure ammonia liquid. So again it go to expansion valve. Again it goes to a expansion valve. So in expansion valve, high pressure is converted into low pressure, high temperature converted to low temperature. Again it comes to evaporator, low pressure, low temperature, ammonia liquid enters to evaporator. Second time it is going to change the state. That is, in the evaporator, the liquid refrigerant. Okay, liquid refrigerant, it is going to evaporate to atmosphere. While it is evaporating, it takes the heat present in the refrigerated space. It will go to the atmosphere. It will go to the atmosphere. That means one cycle is complete. Again the ammonia vapor comes to the absorber. Okay, so one cycle is completed. This, like this, you have to repeat the cycle several number of times as long as the desired temperature is achieved in the refrigerated space. Okay, the same story or the same thing. That is, again once it is heat increases, again the cycle starts. It has to maintain. Okay, it has to maintain. So this is vapor absorption refrigeration system. The parts of vapor absorption refrigeration is the absorber, pump, heat exchanger, generator, condenser, expansion valve, evaporator. Working of vapor absorption refrigeration system. It takes place in the following stages: absorption of ammonia vapor and production of strong ammonia solution. Where it will happen? It's the absorber. So in the absorber, ammonia vapor is absorbed and becomes a strong ammonia solution. Strong means concentration of ammonia particles are more. That is called strong ammonia solution. Next, production of ammonia vapor. How the ammonia vapor is produced? By generator. So generator produces the ammonia vapor. Okay, so it converts liquid ammonia into a vapor ammonia, high pressure vapor ammonia. Next, condensation of ammonia vapors into liquid ammonia. So where condensation takes place, ammonia vapor is converted into liquid ammonia. Next, second, again expansion of liquid ammonia and absorption of heating and cooling space. So these are the stages in which the vapor absorption refrigeration system takes place. Next, difference between vapor compression and vapor absorption refrigeration system. First, see, vapor absorption works on heat energy. So works on heat energy. That means vapor absorption works on fuel and heat energy. But vapor compression, mechanical energy, because the compressor is there. So the compressor means mechanical parts are there, mechanical parts, because of mechanical energy it utilizes. So no need of electric power for vapor absorption. So it needs electric power to drive the compressor. So it needs electric power to drive the compressor. Next, less mechanical energy is needed here. Here more mechanical energy is needed because compressor is there, more mechanical energy is required. So soluble refrigerants are used because soluble refrigerants, that means ammonia dissolves in the water so that we can use. Okay, but here in this any refrigerant can be used. So vapor refrigerants absorbed and heated. Vapor refrigerant is absorbed here and also heated, but vapor refrigerant is only compressed here. So no noise here and more noise here because compressor makes a noise. So maintenance cost is less, here more maintenance cost is there. Okay, next, more capacity can be built. So the vapor absorption, more than 1000 tons, the capacities can be built. That is such a big unit you can build, but you cannot build more than 1000 ton refrigeration. No refrigerant leakage, chances of refrigerant leakage is there. So COP is less in this case, vapor absorption, but COP is more in the case of vapor compression refrigeration system. So this is all about the vapor compression refrigeration system and vapor absorption refrigeration system. Thank you for watching the video. Thank you. Again, we'll meet in the next lecture class 3.